Hello, dear student. How are you? I hope you are all will be fine. I'm also fine. Thank you. Today is lecture number 8 of nucleophilic substitution reaction. And today lecture, in previous lecture, we end up the Sn2 reaction. But in today lecture, we will be studied about and the coming lecture in today lecture we will be study about Sn1 reaction. That what is unimolecular substitution nucleophilic reaction. So we will be study this nucleophilic substitution reaction of Sn1 reaction. After that we will be compare Sn1 and Sn2, what is the differences between Sn1 and Sn2, what is the similarity between Sn1 and Sn2. But first of all we will be study one by one. I already explained you Sn2 with very detail in previous 7 lecture. So in coming lecture we will be studying Sn1 reaction. So let's start Sn1 reaction. Yeah, today we will be studying about Sn1 reaction, that is called unimolecular nucleophilic substitution reaction, that is Sn1 reaction. Yeah, what is meant by Sn1 reaction? Sn1 reaction, when tertiary butyl bromide, like that is tertiary butyl bromide, that is bromide, that is CH3, here is 3, which is very bulky. When tertiary butyl bromide is placed in boiling methanol, what is the formula of methanol? CH3OH, that is the formula of methanol, or you can say that methyl alcohol. When tertiary butyl bromide is placed in boiling methanol, means methanol is solvent, sir. So the methyl tertiary butyl, this is ether. The methyl tertiary butyl can be isolated from the reaction mixture. When these are reacted, they form mixture, and the methyl tertiary butyl ether, that is CH3 CH3 3, that is methyl tertiary butyl 3 OCH3. OCH3. Yeah, this is tertiary butyl. This is methyl tertiary butyl ether. This is methyl. This is tertiary butyl. So methyl tertiary butyl ether. This is the formula of ether. So from the solution, from the mixture, the methyl tertiary butyl can be isolated from the mixture. Because this reaction take place with the solvent acting as the nucleophile. This solvent acting as a nucleophile. But in Sn2 reaction we already said that nucleophile is used separately, not the solvent is used as a nucleophile, but nucleophile will be used as a solvent separately. For example, where is H2O as a solvent, so when we add substrate and nucleophile in the solution, and the mixture in the water in the solvent, after that Sn2 reaction take place. But here solvent also take part is a nucleophile. So that's why it is also called, this process is also called solvolysis. What is meant by solvolysis? Salvo means it is used for solvent, while lysis is used for splitting, or you can say cleavage. So it is mean that here is the splitting of or cleavage of solvent will occur in Sn1 reaction. In previous reaction, this solvolysis is substituted because methoxide has replaced, this is methoxide has replaced this bromine, and on the tertiary butyl group, this methoxide replaced this bromine on the tertiary butyl. However, the Sn2 requires a strong nucleophile. In Sn2 it requires separately strong nucleophile, while methoxide ion, or you can say methanol, is not enough strong. That is like the nucleophile that was used in Sn2 reaction. Also in methoxide in Sn2 reaction, the substrate shouldn't be very bulky group. The substrate shouldn't be very bulky, because bulky group, more the bulky group, it will hinder, it will steric the it will steric the reaction, it will reduce the reaction, the rate of reaction will be reduced. But in case here more is the bulky group, more will be the rate of the reaction. So that's why it is not the Sn2 reaction. This reaction have their own mechanism, it will have their own ways of reaction. So it will have their own way of the rate of the reaction, it will have their own way, because tertiary butyl it is very poor substrate in case of Sn2 reaction, while it is very good substrate in case of Sn1 reaction. So Sn1 and Sn2 is very different from each other. Yeah, if this substitution cannot go to the by the if this substitution cannot go by Sn1 Sn2 mechanism, because here is very bulkiness, and the nucleophile is also very weak nucleophile, very poor nucleophile. So what kind of mechanism might be involved? So that's why here is only tertiary, here is only Sn1. This mechanism will be called Sn1 mechanism. While Sn1 mechanism, it is used, it is mostly the first order reaction, it is mostly the first order reaction. First order reaction, Sn1 reaction are mostly first order reaction. It means the rate is only depend upon the concentration of the substrate, not depend upon the solvents. In first order reaction or in Sn1 reaction, rate of the reaction only depend upon rate of the reaction only depend upon the concentration of the substrate, not on the concentration of the solvents. So you can write that rate will be equal to where K, here in K for tertiary butyl bromide, in methanol, the rate of the reaction will be, rate is equal to K into CH3 CBr. This will be the rate of the reaction, this will be the rate for this reaction, because the overall reaction is the first order reaction. That's why the reaction will be only depend upon the one reactant, that is the substrate. I hope this point will be cleared. If you have any confusion, you can rewind the video. Yeah, also in Sn2 reaction, where only one transition state obtained, where only one transition state was formed, while in Sn1 reaction, here is different transition state produced. Here two different transition state produced, means Sn2 reaction involve it completely in single step, while Sn1 reaction involve in either it can be completed in 2 steps or it can be completed in 3 steps. It have condition that which reaction will be complete in 2 steps and which reaction need 3 steps. We will be explain this. Yeah, also the Sn1 reaction is Sn1 stand for Sn1 stand for one stand for unimolecular, unimolecular, unimolecular. N for substitution, unimolecular nucleophilic substitution. N stand for nucleophilic, nucleophilic, while S used for substitution. Nucleophilic, unimolecular nucleophilic substitution reaction. This is called Sn1 reaction. In short, it is called Sn1 reaction, unimolecular nucleophilic substitution reaction. That is the characteristic or properties of the Sn1 reaction. It is first order reaction, unimolecular. Here unimolecular means that there is only one molecule. Unimolecular means only one reactant used, only one reactant used in the rate determining step, rate determining step, or you can say in first step only one molecular reaction will be used, or you can say that only one reactant used in the rate in the slow step of the reaction. In slow step of the reaction, only one reactant will be used. This is the first property. The second property is the it is first order reaction. First order reaction. Mostly the reaction of Sn1 reaction will be first order reaction. Means only one molecule will be depend upon the rate of the reaction, and this rate will be directly depend, means with the double of the concentration, also the rate will be doubled. Yeah, this is the first order reaction. Also, Sn1 reaction also complete in it is complete in two or three steps. So complete in two or three steps. I will be explain it later after the explaining of the characteristic. At complete in two Sn1 reaction are complete in two or three steps, while Sn2 reaction complete only in once in single steps. Here two transition state produced two transition state produced are formed. Yeah, here is two transition state produced, while in case of Sn2 reaction, where one only one transition state was produced. This reaction is complete in two or three steps, while the first step will be called rate limiting step. First step of the reaction will be called first step of the reaction called rate limiting, rate determining step, because it is slow step, rate determining step. Yeah, these are the general properties of the Sn1 reaction. I hope these points will be cleared. If you have any confusion, you can also ask me in comment section, as well as you can ask me in my personal WhatsApp email that I drop in description box. In Sn1 reaction, solvent will be act as a nucleophile. Solvent will be act as a nucleophile. Act as a nucleophile. Silent will, solvent will be act as a nucleophile. Yeah, these are the characteristics of the Sn1 reaction. Sn1 complete in a multi-step step, that is two or three steps. You can take screenshot or you can rewind the video. You can pause the video. I'm cleaning the board because lack of space. Also, the one property is the nucleophile is not present in the rate limiting step, or you can say that nucleophile is not present in the transition state in case of Sn1 reaction. So let's start example. Example of the solvabilizes of the substitution we have methoxide ion. Methoxide ion, yeah. Example is when tertiary butyl bromide is placed in boiling methanol. When tertiary butyl bromide CH3 3C when it is placed in boiling methanol CH3OH, it produced when it is boiled it produces CH3 3COCH3 plus HBr. Yeah, it produces this. This is methyl tertiary butyl ether. Methyl tertiary butyl ether. That is methyl tertiary butyl ether. While this is methanol, this is a tertiary butyl bromide. Tertiary butyl bromide. Yeah. So what will be the mechanism of this reaction? What will be the mechanism of this reaction? This mechanism complete in two steps or in three steps, but it is complete in three steps. That is plus HBr. Yeah, this mechanism complete in three steps. What is the steps? Number first step. Step one is also called rate determining step. That is the first step, rate determining step. The formation of carbocation. Formation of carbocation, also called limiting step, rate limiting, also called rate limiting. In first step, first of all, only one reactant will be used in this reaction. That is CH3 Br. First of all, that is Br. This Br is a, here is three bulky groups attached. That is like that, CH3, 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 that is Br. Here is the case like that. Yeah, this Br is high electronegative element, so that's why this Br will be withdraw electrons from this carbon. That's why the bond will become polarized and bromine will be get partial negative charge while carbon will get partial positive charge. But these CH3, these groups, these bulky groups, these methyl, these alkyl groups, they these both these all groups donate electron toward this carbocation. So that's why electron deficiency on this carbon will be increased. Due to this increase in the density of electrons, the removal of bromine will become easily. So that's why more the number of bulky group in Sn1 reaction, more will be the rate of the Sn1 reaction. Means when there is three bulky group attached, or you can say when there is three methyl group, or you can say that when there is three electron donating group attached, it will be go easily to lose the bromide ion, or to lose the the this halide ion, as compared to in case when there is only two electron donating group attached, which will be not enough increase that to increase the electron density on the electrophilic carbon. So that's why in this case the bromine will be lost, like that. This bromine will be lost, because this is partial negative charge and this carbon have partial positive charge. So this bromine will be lost, and the intermediate will produce this is intermediate CH3 3C having plus positive charge and plus Br having negative charge. Also this reaction is very slow reaction, this is very slow reaction. That's why this is, and we know that there is slow reaction and slow step is the rate determined, so this is the slow step one. While in step number 2, nucleophilic attack on this carbocation, nucleophile will be used from the solvent. Nucleophilic attack on the carbocation. So this is carbocation CH3C plus CH3C plus this is the carbocation, which this is the this is methanol is a this solvent will be act as a nucleophile, so it will be OHCH3, and this methanol has two lone pairs, so that's why this lone pair will be act as a nucleophile at attack on this carbon. So the nucleophilic attack occur. After that one product will be formed, that is second intermediate, that will be produced. It will be called CH3 3 CO CH3H, but this oxygen lost one lone pair, so that's why they will get positive charge. This reaction is very fast reaction, this step is very fast step, because here when as the this intermediate produce this tertiary carbocation produced, it will the nucleophile will be the solvent will be directly attack within second, within the part of the second, it will attack on this carbocation. So that's why this reaction will be very fast, and this reaction will be not enough endothermic, like the first reaction, first step is will be first step will be very endothermic, because it is very slow steps, but in case of second step or in case of third step, the most of the energy of the reaction will be lost, means the reaction will become exothermic. In third step, loss of proton to solvent, loss of proton to solvent, which is be like that. Loss of proton will be like that. That is, this structure will be used, CH3 3CO CH3 H plus charge. So here is in solvent that is CH3OH. This oxygen will again act as a nucleophile. It will be act as a base, and it will deprotonate this intermediate. So that's why it will produce product, that will generate product CH3 3COCH3 plus CH3OH2. These are the products of the Sn1 reaction. So it will be complete in three steps. But when here is not neutral nucleophile used, when there is a negative nucleophile used, so that's why in the case of negative nucleophile only two steps will be required to complete the Sn1 reaction, while in case of the neutral nucleophile or neutral solvent, it will be complete in three steps, like that. These are the three steps of the Sn1 mechanism. I hope these steps will be cleared. If you have any confusion, you can ask me in comment section. You can also take screenshot, or you can also rewind the video. This is Sn2 reaction, lecture number 8 of nucleophilic substitution reaction. The first step here, let's repeat. The first step is also called carbon. That is also called ionization step. While the ionization step is very slow steps, because here is ion produced, ion formation produced, and ion formation also it also required a high activation energy. So the activation energy or energy barrier of the first step will be very greater, means the activation energy will be very high. And second step there is a nucleophile will be attack on the intermediate of the first step, that are produced in first step, that the carbocation that are produced in first step. In second step, the nucleophile, or you can say the solvent will be attack on this nucleophile, and this electrophile are in this carbocation. So that's why these carbocation or these nucleophile will be act as a weak nucleophile. When this nucleophile are weak, the reaction will be occur very good. The reaction will be occur. So poor nucleophile will be act as a very high rate of the reaction. It will be produce very high rate, very high speed of the reaction. And also in third step, loss of proton, when there is neutral solvent or when there is neutral nucleophile are used, so third step will be required. In third step, loss of proton will be occur. These are the steps. So let's start the energy profile diagram of Sn1 reaction. For this given reaction, the energy profile diagram will be like that. The energy profile diagram or reaction energy diagram for Sn1 reaction. For Sn1 reaction, yeah, it will be like that. Sorry. this is the energy diagram for the Sn1 reaction. This is energy, and this is the direction of the reaction, direction of the reaction completion. Yeah, when there is when there is initial position, mean there is only reactant are used. This is reactant, and reactant was used, that is reactant are these. Let's suppose the reactant is this is the reaction Rx. This is the first step plus nucleophile. After that it produced nucleophile R nucleophile plus X. But in case of it will be complete in three steps. In case of in first step, it will be Rx plus nucleophile, both are used nucleophile. So this is the first step. It require very high energy. The energy barrier will be very high, and this peak point is called, this is the transition state of the first step. After first step, the intermediate will produce, so this is the intermediate position. Intermediate will be R plus X minus, this will be intermediate, as I already explained you in the previous, in before example is that in this example that I explained you. So these are the intermediates. Plus nucleophile is also present in the solvents. Also the energy barrier, now the energy barrier for the second step will be very lower. It will be like that, this is the energy barrier, the activation energy will be very low, but it will be highly exothermic, means very much energy will be lost. This is the final position of the reaction, means there is product produced now, and the product is R nucleophile will be attacked instead of X. It means X will be R halide ion will be replaced by nucleophile, so plus X halide ion. So these are the energy profile diagram. First of all, this is the first transition point, this is the second transition point, and this is the first step from this point to this point. This is the first step. In first step, the transition position will be produced. After the transition, intermediate will form. After the intermediate, the second step will require less of the first step, will be require very much. The first step will be high energetic, it will be high endothermic. First step will be high endothermic. This is the first step. This is the transition state of first transition state. First transition state will have very high energy. This is the first step. This is the first step, while this is the second step. The second step, this is the second step. The second step will have very high exothermic, being totally the net energy of the system will be loss of the system, means the system will be reduced energy. That's why the energy of the product will be decreased, and the product will be more stable product as compared to the reactant. Product will be very stable product, because its energy is lower than the reactant. So these are the energy profile diagram of the Sn1 reaction. I hope this will be cleared. If you have any confusion, you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I drop in description box. You can get from there. In next lecture, inshallah, we will be studying the substituent effect on Sn1 reaction, also leaving group effects, also solvent effects, also stereochemistry of Sn1 reaction. We will be studying that with very detail. Also rearrangement in Sn1 reaction, we will be studying that. If you have any confusion, you can rewind the video. It will be clarify your confusion. Also please support my channel, subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you, very best of luck my dear student, very best of luck.